Hello viewers, in today's session we are going to discuss the solution of this logarithmic equation. So here we have to solve this logarithmic equation where we have logarithm of 2 over 1 minus x to the base 5 minus x equal to logarithm of 2 minus x to the base 5 minus x, right? So in order to solve this type of logarithmic equation, let us first consider the general form. So suppose we have an equation of this form, that is logarithm of say p of x to the base b of x is equal to logarithm of uh, q of x to the base b of x, right? So here this equation is similar to this one. Now if we compare both these equations, then we get the base, that is b of x is 5 minus x, and here we have p of x is equal to 2 over 1 minus x, and q over x, q of x is equal to 2 minus x, right? So in order to solve this type of logarithmic equation, what we have to do, we first take p of x is equal to q of x, right? Because here the base of this log is b of x, and here the base of this log is b of x. So the first condition is p of x should be equal to q of x, and then we must have b of x should be greater than 0, and b of x should not be equal to 1, right? And moreover, p of x and q of x must be greater than 0. That is, we should have p of x should be greater than 0, and q of x should be greater than 0. So here we have these conditions, right? So whenever we deal with these kind of logarithmic equation, then p of x should be equal to q of x, and in order to define the domain, then p of x should be greater than 0, and q of x should also be greater than 0, and the base, that is b of x, should not be equal to 1, and b of x should be greater than 0, right? So we have these conditions. So here, to get the solution of this equation, now let us start with uh, this equation. So here we have p of x is equal to q of x. So we must have 2 over 1 minus x equal to 2 minus x, right? And here b of x is greater than 0. So this implies that 5 minus x should be greater than 0, and then b of x should not be equal to 1. So we have 5 minus x should not be equal to 1, and then p of x should be greater than 0. So this gives us 2 over 1 minus x must be greater than 0, and q of x should also be greater than 0. So we should have 2 minus x greater than 0. So now the solution of this equation is that value of x which satisfies all these conditions simultaneously, right? So let us start with this equation. So here we have 2 over 1 minus x is equal to 2 minus x. So we can now write here 2 is equal to 2 minus x times 1 minus x. So here we can get a quadratic expression. So we have 2, then we can multiply these two binomials. So we have 2 1 minus x, then we have minus x and 1 minus x. So we can now write 2 minus 2x minus x plus x square. So we have here x square, then we have minus 3x, and then we have here plus 2, right? So now this 2 and this 2 get cancelled, and we are left with x square minus 3x is equal to 0. So now this is a quadratic equation, so we can take x common. So we have x minus 3 is equal to 0. So now here we have two linear factors, so we must have x is equal to 0 or x minus 3 is equal to 0. So from here we have x is equal to 3. So now we have obtained two values of x using this condition, that is p of x is equal to q of x. So we have two values of x, 0 and 3. Now let us see whether these values satisfy these conditions, right? So now let us first consider x is equal to 0, and now if we take x is equal to 0 in these conditions, then we can see that here we have 5 minus 0, that is 5, and 5 is obviously greater than 0, and here we have 5 minus 0, that is 5, and 5 is not equal to 1. And here also we have 2 over 1 minus 0, that is simply 2, and 2 is clearly greater than 0. And here also when we take x is equal to 0, then we have 2 is greater than 0, which is a true statement, right? And this follows that x is equal to 0 is a solution of this equation, and we can also directly substitute x is equal to 0 in this equation also. So taking x is equal to 0 in this equation, we have log of 5 minus 0, then we have 2 over 1 minus 0, and here we have log of 5 minus 0 and 2 minus 0. So from here we have log of 5, here we have 2 over 1, that is simply 2, and here we have log of 5, and here we have 2, and we can see that the left hand side is equal to the right hand side, right? So x is equal to 0 is a solution of this given equation. Now let us consider x is equal to 3. So now when we take x is equal to 3 in this inequality, 2 minus x is greater than 0, then we have 2 minus 3 is greater than 0, and here we have minus 1 greater than 0, and this is a false statement because minus 1 cannot be greater than 0, right? So this implies that x is equal to 3, it doesn't satisfy this inequality, right? And similarly x is equal to 3 does not satisfy this inequality also, because if we take x is equal to 3 over here, then we have 2 over 1 minus 3, that is equal to 2 over minus 2, and here we have minus 1, and from here we get minus 1 greater than 0, which is again a false statement, right? So this implies that x is equal to 3 cannot be a solution of this equation, right? So this is how we can easily solve these kind of logarithmic equation using these conditions. So x is equal to 0 is the only solution of this logarithmic equation. Hello viewers, in today's session we are going to discuss the solution of this logarithmic equation, where we have logarithm of x minus 4 to the base x plus logarithm of x plus 3 to the base x is equal to logarithm of 5x plus 4 to the base x, right? So let us see how we can solve this logarithmic equation using the concept of domain of logarithmic function, right? And here we'll convert this equation into a quadratic equation, right? So let us start. So let us first define the domain of these three terms. So here we have logarithm of x minus 4 to the base x, right? So here this term is defined when we have x minus 4 is greater than 0, and this base x which appears in all these three terms, this x should be greater than 0 and x cannot be equal to 1, right? And here we have a log of x plus 3 to the base x, right? So x should be greater than 0 and x cannot be equal to 1, and moreover here we must have x plus 3 greater than 0, and here we have a logarithm of 5x plus 4 to the base x, right? So here x should be greater than 0 and x should not be equal to 1, and here we should have 5x plus 4 greater than 0, right? So here we have these conditions, that is x minus 4 should be greater than 0, then we have x plus 3 greater than 0, and then we have 5x plus 4 greater than 0. So these terms should be positive, and the condition on x, which is the base of these three logarithms, is x should be greater than 0 and x should not be equal to 1, right? So this system has some solution when we have these conditions, right? So here only those values of x satisfy this equation which fulfills or which satisfies these constraints, that is x minus 4, x plus 3, 5x plus 4, and x should be greater than 0 and x should not be equal to 1. So now let us make use of this property of logarithms, that is log of m to the base a plus log of n to the base a is equal to logarithm of m times n to the base a, right? So here in the left hand side we can make use of this property. So here we have logarithm of x minus 4 times that is, here we have x plus 3 and here the base is x, right? So here a can be taken as x and m is x minus 4 and n is x plus 3, right? So we can write the left hand side like this using this property, and in the right hand side we have log of 5x plus 4 to the base x, right? Okay, so now we can compare both these sides. So here we have logarithm of the product of these two binomials, x minus 4 and x plus 3 to the base x, and here we have a logarithm of 5x plus 4 to the base x. So if we compare both sides, then this term is equal to this one, that is x minus 4 times x plus 3 is equal to 5x plus 4, right? So now let us multiply these two binomials. So we have here x times x plus 3, then we have minus 4 times x plus 3, and here we have 5x plus 4, right? So here we have x squared, then we have 3x minus 4x minus 12, and this is 5x plus 4. So now let us rearrange the terms here. We have x squared. This is 3x minus 4x is minus x. And we can take 5x to this side. Then we have minus 12. And we can take 4 to this side. So we have minus 4. And this is equal to 0. So we have x squared minus 6x. And here we have minus 16 is equal to 0. So now we have a quadratic equation, and we can solve this quadratic equation either by using the method of splitting the middle term, or using the quadratic formula, that is x is equal to minus b plus minus square root of b square minus 4ac over 2a, where the discriminant d is b square minus 4ac, right? So here we'll make use of the method of splitting the middle term. So we can now write x square, and here we have minus 8x, and then we can write 2x, and here we have minus 16 is equal to 0, right? So here we have the two numbers minus 8 and 2, and the product is minus 16, and here minus 8 plus 2 is equal to minus 6, right? Okay, so now we can write here x minus 8, then we have 2, here we have x minus 8 is equal to 0. Now we can write x minus 8, here we have x plus 2. So here we have the two linear factors. So the roots can be given by x minus 8 is equal to 0, and x plus 2 is equal to 0. So from here we have x is equal to 8. From here we have x is equal to minus 2. So this quadratic equation has two roots, 8 and minus 2. So now let us consider the value of x, that is minus 2, and let us see whether this value satisfies these conditions. And we can easily see that the first condition is not satisfied by x is equal to minus 2, because if we take x is equal to minus 2 in this inequality, then we have minus 2 minus 4 greater than 0, that is minus 6 is greater than 0, which is a false statement. And similarly this value does not satisfy x greater than 0, because minus 2 is greater than 0. This is again a false statement, right? So we can reject this value of x as a solution of this equation, right? So we are now left with x is equal to 8, and let us see whether x is equal to 8 it satisfies this equation or these conditions. So now if we take x is equal to 8 in these conditions, then we can see that 8 minus 4, that is the first condition, 8 minus 4 is 4, which is greater than 0. So this is true. And here we have 8 plus 3, that is x plus 3. So 8 plus 3 is 11, and 11 is greater than 0. And this is again a true statement, right? And similarly here we have 5 times 8 plus 4, that is 5 times 8 is 40, 40 plus 4 is 44, and 44 is obviously greater than 0. This is again a true statement. And here we have x greater than 0, so 8 is greater than 0, which is again a true statement. And here x is not equal to 1, so obviously 8 is not equal to 1, so this is again a true statement. So we can see that x is equal to 8 it satisfies all these conditions, right? So x is equal to 8 is a solution of this logarithmic equation, and we can also verify whether x is equal to 8 is a solution of this equation or not by substituting x is equal to 8 in this equation. So now let us take x is equal to 8 in the left hand side. So we have here a logarithm of 8 minus 4. Here we have the base 8 because x is equal to 8. Then we have log of 8 plus 3. Here we have 8. So now we can write logarithm of 4. Here we have 8. 8 minus 4 is 4. Then we have log of 11 to the base 8. So now again using this property, we have logarithm of 4 to the base 8 plus logarithm of 11 to the base 8. So here the value of a is 8, m is 4, and n is 11. So we can now write here logarithm of m times n, that is 4 times 11, and here we have the base 8. So we have logarithm of 44 to the base 8. So the left hand side is logarithm of 44 to the base 8. So now in the right hand side we have logarithm of 5 times 8 plus 4. Here we have 8, and this is log, this is 40. 5 times 8 is 40. 40 plus 4 is 44, and here we have the base 8, right? So we can see that the left hand side is equal to the right hand side, because here we have logarithm of 44 to the base 8. Here also we have logarithm of 44 to the base 8, right? So the left hand side is equal to the right hand side, and this confirms that x is equal to 8 is a solution of this logarithmic equation. So this equation has only one solution, that is x is equal to 8, and x is equal to minus 2 is not a solution of this equation, as this value of x, it does not satisfy these constraints.